So this system here is the same, obviously same box, but we're running the different boot environment, the Trusted Extensions boot environment. I'm going to log in as JDoe. So we're running Trusted Extensions now, and one of the differences that you'll see is that some of the RBAC information for this session is always displayed when you log in. Again, Trusted Extensions, which is derived from Trusted Solaris, went through a number of different evaluation criteria, including the compartmented mode workstation historically and the ITsec before it went through common criteria. So there were a bunch of other historic requirements that we met, including the fact that the user needed to be told what his rights were during login, and this is where that's done. And the next screen is where the user could, in this case, provide a more restrictive clearance, although I'm going to leave the defaults up here for right now. And we see that we're going to be leaving the clearance alone, confidential need to know, but we could have actually created a single level session just at the ozone label. And now we see we're running Trusted Extensions. It's Open Solaris. As Christoph explained, it's not just Open Solaris, it's the same Open Solaris that Christoph was running, because in order to create this environment, we actually simply did a BEADM create, that's a boot environment administration create, which cloned the global zone effectively and the ozone, and then we enabled Trusted Extensions, and I'll talk about that more specifically at the end. I wanted to talk about what's different. You see on the top, we have this other stripe, a stripe called the Trusted Stripe. It has a bunch of menus associated with it, which we call the Trusted Path menu. We also have an interface here for changing the label workspace, which we could actually, if we had other zones created, we could switch to those other labels. And we have labeled workspaces along the bottom, which will become more meaningful. I might as well do this one now just to point out it's here. Before, when Christoph showed how he did an SU to the auditor role so that we could do the auditing demo, in Trusted Extensions, everything's done graphically. So the way, instead of using the SU command, we use a graphical interface that effectively is like SU. Is this one L1A admin, or is it test 1, 2, 3? Okay. Actually, I now have another background. Obviously, you can see if I switch between these two workspaces, we have a different desktop background, and that's to kind of emphasize the point that these are, in fact, different sessions. But we call this a multi-level desktop because we're running multiple sessions concurrently on a single login. The other thing is that we didn't just switch to a different user. The reason we don't use SU in Trusted Extensions is because the GUI for switching roles and assigning roles is zone aware. It actually switched me into another zone. So I switched from the O zone into the global zone at this point. And the way it's reflected in Trusted Extensions, we don't like to use the word global zone. It's kind of very Sun specific. The term in the industry is Trusted Path. So the word Trusted Path shows up on the windows that are running in the global zone, and the word ozone shows up on the windows that are running in the ozone zone, and therefore it's much more apparent what's going on. And I'll come back, and I just want to introduce the basic elements of the desktop. So I'm going to go through my slides. If I figure this one is, which one's me? TX Lisa. Okay. So I'm not going to go full screen on this because I'm going to want to switch back and forth. I'm going to presentation. And where am I at I'm at the end. Oh, sorry about that. I didn't start in the beginning. Is there a menu to go to the beginning? Roll mouse back, forward, goes to the beginning? Oh, that way, yeah, but I mean, it wasn't one button that would do it. All right. This is Christoph's picture from a park he visited where they're trying to break into the bear trap or whatever, something like that. So let me first historically just give you a little background because terms get confusing. I've been with Sun for over 20 years, and I was hired more than 20 years ago to develop a multi-level desktop. And the first multi-level desktop that we did at Sun was based on SunView. I don't know if anybody even remembers there was such a thing as SunView before there was X, before there was News. And then we did one based on X11 News, and then one based on pure X11, based on Common Desktop Environment. So we had OpenLook, SunView, OpenLook, the Common Desktop Environment, and now GNOME. So this is an interesting story only because Sun never gave up on this, and it turned out it took a long time before this was actually a successful marketplace. But I was always surprised that nobody else did this. Even though there is some work in the SE Linux community, we still have the only multi-level desktops that ever ran on CDE, and the only multi-level desktops that run under GNOME. Although there are efforts, there are other X things, there's an Xbox, not Xbox, what do they call that? BusyBox and the other one. There are other desktops that you'll see that are using multi-level features. But we have the important point of this presentation is that Trusted Extensions is not a different operating system or a different install, or even different set of procedures. It's the same operating system. It is Solaris. We're running the same tools. Mostly the differences are in the desktop. The graphical user interface is more label-oriented and more visual. But otherwise, it is still Solaris. In this particular presentation, we only really have two labels. The Trusted Path label for administration in the global zone, and the Ozone label, which is, we just chose the name Ozone to match the name of the global zone, but they don't necessarily have to match. In a real environment, there would typically be far more labels, and there would be a zone for each label. The words that you use for the labels is completely free form. People seem to think that maybe there have to be words like top secret and classified, confidential, whatever. There's no real prejudice to those words. Any words will work. So that's why we chose to call Ozone the label that we're using here. The labels may have a relationship, and I'll talk about that in a minute. We rely mostly in our implementation of mandatory access control is mostly leveraging standard features of Solaris. So zones actually implement most of the features of mandatory access control just by default, although Trusted Extensions has a few additional constraints on what zones can do, and I'll go through them in a minute. So, of course, the other thing to be aware of is that in some environments, Trusted Extensions and systems like it are mandated, often in the federal government and other governments and financial communities where data separation is a legal or business requirement. Trusted Extensions is required, but it is not actually a product. Trusted Extensions is simply a service that you enable when you're already running Solaris. It doesn't require a special contract or service agreement or even an installation procedure. Labeling is a very loose term, and even in the computer business, it doesn't have a very precise meaning. So what we're talking about here is a sensitivity label, that is how valuable the protection should be for particular types of information. And in Trusted Extensions, we label everything that might have some interesting information in it. But unlike other systems, including the predecessor of Trusted Extensions, the Trusted Solaris system, most of the labeling is actually implicit based on the container that it's in. So we don't actually store that many labels persistently. Most of the labels are derived dynamically. But everything is in fact labeled that's interesting. Labels can have a relationship that is hierarchical or disjoint. Of course, in this case, where we only have two labels, the hierarchy is a little bit interesting in that the global zone is just really very separate. The global zone is kind of special in that it has special rules, but normally zones would have a relationship that they would have one zone would be of a higher or lower label than the other one, or they would be completely disjoint. And these rules are defined in something called the Label Encodings Database, which is a piece of code we got from the DIA 20 years ago that we're still using. The rules for sharing of information is generally controlled from the global zone. So it is possible for zones to share information, but there are a number of restrictions. So by default, zones can't share any information with each other, nor can they communicate in any way with each other, including networking. So when you enable trusted extensions, zones are isolated completely. All the system services that would pass data are blocked between zones. This includes doors, for example, Unix domain sockets, anything that you can think of that might be a way to convey information, including the file system. So by default, if sharing is configured, the first restriction is that sharing is read-only, and furthermore, the reader's label has to be greater than the object's label. And the administrator can't make a mistake because the the kernel will not allow the administrator to make a mistake. So there aren't a contrast, and I know some of you work on SE Linux, so a contrast is that mostly trusted extensions is not as flexible and doesn't implement flexible mandatory access control. It implements fixed mandatory access control, so that the administrator is not really allowed to change the policy in such a way that would violate the normal Bell and LaPadula rules. That is, it is based on dominance and label relationships. So here's an example of what gets labeled. This is on slide 4. We explicitly can associate labels administratively with users and roles, that is clearances or label ranges for those users, and we also must associate labels with zones, and they're unique labels, one label per zone. We can also associate labels with hosts and networks. ZFS datasets can be labeled, and X11 windows are labeled. GNOME workspaces, as you've seen, are also labeled. And from that, we derive implicit labels. So processes they're labeled in the sense that you can query the system and it will return the label of every process. But we don't actually have a label structure in the kernel associated with processes. We derive it from the zone. So the kernel knows what zone is associated with every process, and the kernel also knows what label is associated with every zone, so indirectly every process is labeled. Similarly, every file and directory is associated with a ZFS dataset, and we know the label of every ZFS dataset, so we know the label of every file and process, but every file and directory, I should say, but again, unlike SE Linux, we don't label individual files and directories. So if you want to have two directories with different labels, you have to make them different data sets. Similarly, we create devices in zones, and therefore they have the label of the zone they're in. Sockets have the label of the process that created the socket, and SIM4, System 5 IPCs. Pixels have the label of the window that they're contained in. That's the general rule. So everything, you can query the label of everything, and the system will make it look like everything has a label, but in fact, they're mostly implicit. Zones are an exception because if you don't have a label associated with a zone, you can't boot it. So we talked about zones now twice in two different presentations, so I don't need to explain anything more except to say that the major difference and the only real difference in trusted extensions is because each zone has a unique label, they never match. And because we said reading and writing requires label equality, they never equal, and therefore they can't talk to each other. So zones don't, in general, have any way to communicate with each other. We do have, get into networking briefly and point out that we do have a multi-level port, which is a special way for zones to do network communication. And We also have the file sharing, which is a way of doing read-only sharing. So architecturally, everything sits on a single kernel and a single global zone, and then we can have one or more labeled zones that each one having a different label. And applications, each of these, this layered architecture has a specific purpose. So of course, as I see, I'll go through and explode it a bit, but different functions are occurring at different levels hierarchically. So this is what together produces the multi-level architecture, but independently, we start off with the kernel. It's at the kernel level where features like multi-level networking, the file system mount restrictions, the containment by zones, some of the resource management and bandwidth management and things of this sort that are done in the kernel are label aware, and that is because they are zone aware, they're label aware, and we have all kinds of access, both resource management and access control policies being implemented in the kernel. At the next level up in the global zone, which we call the trusted path, that's where the administrators run. So normal users have no direct access to the global zone. There are services that they rely on, including authentication, but they don't actually have the ability to start arbitrary processes in the global zone. So in this case, I'm logged in as JDO, and JDO can't start any processes, arbitrary processes in the global zone. But we have services like printing and auditing, device management, labeled the X window manager runs in the global zone, and the GDM, that's what I mean by single sign-in here, ran in the global zone. And then at the top, this is where we run normal applications, databases. The Oracle database is running here. And we can run any normal Solaris process. We didn't say this very clearly, but it should be obvious. Virtually everything in Solaris runs in zones, and anything that runs in a zone also runs in a trusted extension zone. So we don't have a list of applications that are qualified to run trusted extensions because the list is the same as the list for Solaris. As far as networking is concerned, in 1 minute I'm not going to be able to explain networking except to say that there's a lot of complexity here. I said if you look at this diagram, you'll see that there are no horizontal arrows going between the zones because they generally can't talk to each other. Each zone is assumed in the typical configuration to have its own intranet or classified network that it is exclusively bound to, and that's the way these systems are generally deployed. And we also have some multi-level services that are typically enabled in the global zone, like the X server, that can accept requests at multiple levels and honor the multi-level security. Yes, question?
How is each zone bound to a specific network?
The question is, how is each zone bound to a specific network? And the answer is in a variety of different ways. So that's why I don't have a simple answer. We have both the exclusive stack and the shared stack configurations. Each zone, which, however it's configured, there is in the global zone, we associate rules for IP addresses and interfaces. So the global zone associates the rules for which remote hosts each zone can connect to, typically by network or by IP address. And we also have the multi-level networking using something called CIPSO, Commercial IP Security Option, which is a part of the IP header that specifies a label of every packet. So the kernel interprets packet labeling and routes packets to the appropriate zone based on the CIPSO header or the implicit label associated with that IP address, the source IP address. So, as of yesterday, we now have labeled IPsec in Open Solaris. So labeled IPsec is similar to CIPSO, except that the labeling is done through the Security Association and is therefore protected through encryption. And so we now have, this is now is a little bit soft in my definition of now, because you won't see it for a few weeks in terms of being in the Open Solaris repository, but it was put back into Open Solaris yesterday, the labeled IPsec feature. Another thing that we have is the ability to run arbitrary levels of virtualization, and this is a particularly strange but useful feature. In addition to each zone being a virtualization environment in which they appear to be separate instances of Solaris, you can also run VirtualBox in each zone and then run arbitrary guests inside of VirtualBox. And you might think this would not work well, but it actually works pretty well as long as you don't push it too far. That is, the graphics, VirtualBox has high-performance VirtualBox guest editions, drivers for DirectX and XGL, and so you can run Google Earth, for example, in a Windows guest running inside of VirtualBox, inside a labeled zone, inside of Open Solaris or Solaris, and the performance is pretty close to native. You wouldn't really generally know. I mean, assuming you have the right hardware, if you have a good graphics controller on your laptop, you'll get pretty good performance. And the only thing you can't push is too far. I've done demos. I don't have it set up on this machine. I've done demos to show I can run 2 VirtualBox Google Earth demos in parallel, and it works if you have a pretty powerful laptop. You run out of memory pretty fast. That's basically it. So I mentioned that we also typically associate each zone with its own network. And the way that's done is, of course, we're a hardware company. We can produce systems with lots of network interface cards on them. And we allow, therefore, each zone to have its own physical hardware for its own physical NIC. And each of those NICs can be directly connected to a restricted network. And then the applications running on those networks are classified based on the label we associated with that zone. So most of the time, the applications are actually running Microsoft Windows through terminal services of some kind, whether it's Citrix or the Sun VDI solutions. So therefore, all the windows are labeled, and they can run on either a Sunray device or a laptop, or it doesn't particularly matter. One thing to be aware of is that Trusted Extensions works on Sunrays and looks exactly the same on Sunrays as it does on a laptop, as we're showing to you right now. So the way this system was produced was after Christoph and I put together the system running standard Open Solaris. We got everything running. We got the Oracle service running and everything that you saw. Then we ran this command called beadm create, which is boot environment administration. We created the TX125, which made a ZFS snapshot and clone of the current environment. We made it well, you don't have to. Christoph, at the end of his previous talk, made it, you can show you can specify which one is the default, the boot environment. You can activate one or the other, but we rebooted to that environment after it was made active. I had to halt the ozone because there are some restrictions in Trusted Extensions. It doesn't really want to run. It wants to prevent you from accidentally running zones from a non-labeled environment in a labeled environment. So I had to fool the system into thinking that it didn't have any zones, so I just detached it. Then I enabled Trusted Extensions, which is done by the service administration of enabling the labeled service, labeled daemon service. Rebooted it, system comes up running Trusted Extensions. I then changed the brand of the zone from iPackage, which is the default brand in Open Solaris, to the labeled brand, which is the brand for Trusted. But we didn't actually have to reinstall anything. We didn't have to reinstall the zone, and certainly not Oracle inside the zone. And I just had then to reboot the zone, and we were running what you see here. Now, of course, we did a couple other things like changing the colors and a few other details, but the important point is it just worked. So I'm going to go back and do a little more demo stuff. I've showed you a little more, so let me just kind of finish up before I do a little more demo, about some of the other things that we talked about. We're running open Solaris. Now, most of what I've talked about is the same in Solaris 10. We always, as engineers, like to push our luck a little bit, so this system is running Build 125, which came out about 3 weeks ago. Had we known that we could have gotten labeled IPsec yesterday, we might have pushed our luck and stayed up all night and made it work. But it does have a bunch of new features, and Darren's going to talk about ZFS crypto in a little while. This system has the hooks for ZFS crypto in it already, in that the administrative tool for managing trusted labeled zones already has the crypto commands built into it. And the way we laid out the home directories that Christoph was talking about was actually in anticipation of the way we're going to have to lay them out to get per label and per user cryptographic home directories, which will be cool. And a bunch of other things that are ongoing, as I don't have any more time, but we can talk about. So there's lots of stuff going on. The book here that we're making available is going to be officially in bookstores real soon, in a couple of days, I guess. And it has a chapter on trusted extensions as well as everything else that we've talked about today. And I have a blog that typically talks about new things that are coming in trusted extensions or in Solaris in general, so you can look at that and get more information. So the other thing I was just going to kind of finish up with is I'm going to switch to this environment, the same thing that Christoph did, but now I'm running, the ID here is the auditor. I'm going to do the same demo that Christoph did with the showing, let's see, that's because, why did that happen? Because, I have to delete it first? I didn't think about that. Let me just do something else then. I'll go over here, I'll assume the Oracle role. And we see we get another color here. And if we wait a while, this is Oracle role running with Ozone. There it is. So in this window here, I'm running as Oracle. I'll come back to the auditor window, and I probably just need to delete something. Oh, it's because I have two non-terminated ones. That was the problem. Okay, so let me start this over. Well, you can. Yeah. Temp has, it's actually in. Now, what I have to do here to become root, I have to fix the demo up. The demo failed, so I have to be root to fix it. And nobody on the system can become root except Christoph and I. I mean, the JDO and the auditor, nobody can become root, so I have to effectively come back in again. So there's two of these not terminated files. That's why this is screwed up. This one is broken. Okay. So this is the same demo that Christoph did, except I'm going to do it in a slightly different way. I'm going to move, I'll do it from here. I'll move this Firefox instance into this zone. So it's still running in the same zone. You notice that the window labeling still reflects which zone each process is running in. And if I run something there are those, there's the audit log of those commands. So I'm able to clearly distinguish what's running and how that environment works. So I'm out of time, but I can take questions, and we'll also be able to show the system at some later time. Let me start in the back we were first.
So I take it that from patch management.
Hang on. Who? Okay.
From a patch management,
It should be on. It's good. It's on.
from a patch management standpoint, it's not.
On the
Oh,
bottom is a
he's
switch.
adjusting it in the back.
Hello?
Let me see. Yeah, it's on.
All right. So the question is, from a patch management standpoint, everything's the same?
Yeah, there are, first of all, it's kind of a trick question. There's two answers to that question. The general answer is trusted extensions is not a separate operating system, so there aren't special patches for trusted extensions. It's the same as the Solaris patches, and there is in fact no way to not have trusted extensions. When you install Solaris 10, you get trusted extensions whether you want it or not. It's in your kernel all the time, you just didn't know it. But the other part, it's a trick question because there are no patches in Open Solaris. So it's a different, it's a repository-based mechanism, and it's all based on dependencies and versions, and so there are no patches have gone away. Yeah. The general answer is it's Solaris. Trusted Extensions is not a different product. It doesn't have different patches. There was a question over here.
So what's the process of adding additional labels? If you go and what's the process of adding additional labels? Would you go and create a Solaris zone just like a normal administrator would using command line tools, or are there graphical tools that can assist you with setting it up and adding it to GDM and all that?
Yeah, let me show you just quickly here. Oops, when I type,
I keep forgetting to do this.
I forgot to say equals, okay.
Thank you.
So there's a tool called Trusted Extensions Zone Manager. And here is where I would create a new zone. And it's kind of a wizard. It walks you through the steps. So you would, I'm not going to do one now, but I mean, I could fake it. I could just, new zone something or other.
The other question to parallel that would be, I would assume that
See, just to finish your answer, see, if I want to create a new thing, I'd pick a new label. I'm creating a new zone. I could say the new zone has a confidential label, and
would that actually create the zone for you?
The next step is what I want to do to it, and here's the install. Or if I had another zone, I could clone from a snapshot of another zone. So at this point, it's a kind of a question of what you mean by create. There's a set of steps you got to go through, and this is the wizard to go through those steps.
When you click on that, does it install the zone, or does it say this is the command you run to go install a zone?
It will do an install.
Okay.
But,
So it actually does it.
I can't do an install now because it's a network install and I'm not on the net.
Right. The other question is there any? This is all about multi-labeled desktop. So effectively, there's no real value in trusted extensions for somebody in a server environment.
No, that's not true at all. Depends what you mean. So server environment, again, we're running Oracle server here. I didn't repeat what Christoph did, but we're running an Oracle database in the ozone. I mean, obviously, because it's nice to show desktop, it's much more graphical than showing a server, but the Oracle server was running in that zone. But as far as, I think your question is, what are some multi-level services that might be interesting that come with trusted extensions? Is that really where you're going with this?
Well, I mean, it seems like the real value in labeling in trusted extensions here is, like you said, your original project at Sun, which is a what'd you say? A
Multi-level compartmental workstation. Well, but there's other things.
So, I mean, there's a lot of
There
things.
are guards, there are gateways. This system is also a multi-level printer, that jobs submitted from the network will be automatically labeled with top and bottom labels and banner and trailer pages. So it has a multi-level printer server built into it. You can easily, we have a lot of products I didn't want to turn this into a sales pitch, because I'm an engineer.
Well, the simple question is, that people who
there are-
deploy like Apache, MySQL web
There
servers
are-
and wonder
there
if
are-
they should use it.
We have a lot of partners that produce multi-level products. You go to bluespace.com, for example, you'll see a whole range of products that exploit the Trusted Extensions multi-level features. We have a number of assured decisions. Oracle has an Oracle database, runs on top of Trusted Extensions. OLS, which is their multi-level Oracle database, runs on and requires the installation of Trusted Extensions. So there's quite a number of server products that depend on Trusted Extensions or exploit Trusted Extensions that are not desktop-based. But it is true that the largest deployments of Trusted Extensions are desktop, ultra-thin client, multi-level thin client solutions. But a number of guards, gateways, and databases are deployed on Trusted Extensions.
Okay, we'll take the other questions offline, otherwise we'll never
Okay, let
get
me-
even reasonably back on time.
Let me,
So thanks again, Glenn.
thank you.